when you get all these wonderful memory guarantees from Rust, there's obviously a price to pay, and that price is having to always deal with this idea of ownership and borrowing. But there is in fact an alternative. There is a different way of actually taking a variable and actually sharing it around in your code without Rust complaining that you're doing something illegal. So let's take a look at how that works. So what we're going to be talking about is something called reference counting. So I'm going to have RC demo, and it's going to be a new function, RC demo. Now let me show you a very simple scenario. So let's suppose we have a person. So we have a struct called person, and in here we have the person's name, which is going to be a string. Now what I'm going to do is I'm going to give the person a new function as well as a function for printing out some sort of greeting. So I'm going to have import person like this, and then I'm going to have first of all function new, which is going to take the name. That's going to return a person, and here all I'm going to do is I'm going to return a person with this name, like so. And in addition, I'll have a function which is going to be called greet, and in this function we'll print the greeting. So we'll print line, for example, hi, my name is, and then put in self.name, like so. Okay, so we got our person class, and we can start trying to use it, but I'm going to use it in a specific way. So what I'm going to do is I'm going to make a variable for the name. So I'm going to say var name, or rather I'll say let name equals, and then I'll say John dot to underscore string. So that's the variable for the name, and then I'll make the actual person. So I'll say let person equals person new, and I'll specify the name here. All good so far. Now what I'm going to try and do is I'm going to try and print the greeting. So I'm going to do person.greet, but in addition I'm going to try printing the name by itself. So print line name equals, and then printing the name. Now, as you can probably guess, this isn't going to compile. Let's actually try and rebuild. As you can see, the problem here is that we're using the moved value name. So name has been declared here, and everything is fine so far. But when you call this new function, you're moving name, and so you no longer have it available in the local scope. And the question is, well, what can we do about it? One of the options of being able to actually share name between the different locations in your code is to make a reference counted variable, and that's done using a class called RC. So we're going to have a use statement here. So I'm going to say use std RC capital RC. So capital R small c is the class that we're going to be using, and that class allows you to have a variable which keeps the number of references. So it keeps a count to the number of locations in your code where this variable is actually being referenced. And as it turns 0, the variable can be cleaned up, and that way there is some control over the lifetime of the variable. But you do have to change the type of your actual field. So here I will change string to RC of string, and then we'll do the same here. So RC string, like so. And then the construction of the name here is going to change. So instead of just having the string and calling to string on it, we're going to say RC new, and that creates a reference count variable that we can then pass around. We can then both pass it into new and at the same time use it here. So instead of having this idea of the value being taken over, so the ownership going into new, we now have the variable available pretty much all over the place. So I can actually compile this piece of code, and well, there is one more thing that we have to take into account, so to speak, and that is the idea that when you actually try to move this variable into some way, you call a method on it. You call clone, and this increments the reference count and allows whoever is actually using that variable to get its own access to it without having to use the ordinary move semantics. So go again, I'm going to compile this and let's execute this. And as you can see, I have hi, my name is John, but I also have name equals John. So essentially what's happening is we're taking this variable and we're sharing it around and seeing seeing it pop up in all sorts of different locations. Now it's possible for us to actually figure out how many locations in our code keep a pointer to the variable, and we can find this out. So let's change the example slightly. So what I'm going to do is I'm going to put person inside a scope. I'm going to put curly braces in here, and what this means is that person will be cleaned up at the end of the scope, and when we reach the closing bracket here, person is no longer going to need a reference to the variable name, and we can actually use a member of RC to figure out how many strong pointers there actually are to this particular variable. So here what I'm going to do is I'm going to print line. Let's print line, and I'm going to print line, well, I can print line the names certainly, so I can say name equals so and so, and I can print that name has so many strong pointers. So we're going to see the number of locations which actually use name. So here I'm going to put name, and here I'm going to call RC strong count. So strong count is going to give us the number of strong pointers to the variable name, like so. So let's close this up, and I'm going to copy this whole statement, and I'm going to also paste it here, and I'm also going to paste it, well, let's paste it in here, for example. So what do we expect? Well, when you create name, first of all, you have at least one strong pointer already, because that's this particular variable, so we should have a value of 1. But then of course person is also using name, so we should have the value 2 here, but then person gets cleaned up and we should get the value 1. So we're expecting 1, 2, and 1. Let's actually compile the program and execute to see what we get, and that's exactly what we get. So we have one strong pointer, two strong pointers, and then one strong pointer yet again.